AP Calculus AB. This is the fourth video for this section, note 6.5, I believe. We are using the fundamental theorem of calculus, particle motion, and tables. The table shows values of the velocity in meters per second. A particle moving along the x-axis at selected values time t seconds. What is the value of integrating from 0 to 18 of v of t with respect to t represent? This represents a net distance. It is the net distance particle traveled from t equals 0 seconds to t equals 18 seconds. Same table, I just copied it down here. Using a left Riemann sum of 6 subintervals of equal length, estimate the value of integrating v of t from 0 to 18. Well, 6 subintervals. Let's see. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Now, fortunately, each of these have a horizontal length of 3. So delta x is 3. It's not always the case that it's broken up evenly like this, but it is with this table. Using left Riemann sums, we're going to be using the numbers on the left each time. So for this subinterval, we're using 2.3. For this subinterval, we're using 2.7. For this subinterval, we're using the 2.0, etc. So integrating from 0 to 18, the velocity with respect to time, since delta x is the same throughout, we can just take delta x times the sum of the heights. If that doesn't make sense to you, if you just want to say, look, I'm just going to find the area of each of these rectangles, and I don't care if it's a little bit more work, it makes more sense to me, then that's fine as well. So I'm saying delta x is 3, and the heights for the left for 6 of these subintervals are going to be 2.3, 2.7, 2.0, 1.3, 1.0, and 1.7. Once again, if this becomes too abstract for your brain, it's not an insult. It's not supposed to be an insult. When you'd rather write 3 times 2.3, 3 times 2.7, 3 times 2.0, etc., you can do that as well. This is 3 times 11. This is 33. This is the net distance traveled. And we were measuring in meters per second for velocity, so this is meters. On the AP test, you can leave your answer like this. Completely fine. C, this is very similar, but now it says use right Riemann sum. So once again, delta x is 3, because it's the same table. And now we're going to be using to the right, to the right, to the right. Well, I should say, let me rephrase this. So we're using these two together, it's to the right. And these two together, to the right. So integrating the velocity from 0 to 18. I'll tell you what, I'll write this one the opposite way that I wrote this one. So we got 3 times 2.7. So that's from 0 to 3. And then the right y value is 2.7 plus. From 0 to 3, the right value is 2.0. From, let's see, 0 to 3 and then 3 to 6. Now we're going 6 to 9, 1.3. And then we're going 9 to 12, 1.0. 12 to 15, 1.7. And then 15 to 18, 2.1. Essentially, we swapped out this left value for this right value. That's what essentially happened. So then this ends up being like, if you get to this point on the AP test and there's no calculator, you just write this as your answer. If you have a calculator, which would likely happen, you could calculate it out. This ends up being 32.4 meters. I did use a calculator because I am a mental midget. D, use midpoint Riemann sums of 3 subintervals. We were doing 6 subintervals before. So if we use 3 subintervals, we would be going from 0 to 6, and then 6 to 12, and then 12 to 18. Each of those subintervals, the change in x is 6. So we'd be using this middle y value, and then this middle y value, and then this middle y value. So integrating from 0 to 18, the velocity with respect to t, I might have been saying x before, with respect to t, we have 6 times 2.7 plus 6 times 1.3 plus 6 times 1.7. On a free response question, you can leave it that way. It's 34.2 meters. E, using trapezoidal sum of 6 subintervals of equal length, estimate the value. So integrating from 0 to 18, the velocity with respect to time. Tell you what, since these are equal length, I'm going to use the shortcut for trapezoids, which is 1/2 times delta x, and delta x is 3 in this case, because if we're using 6 subintervals, we're going from 0 to 3, 3 to 6, 6 to 9, 9 to 12, 9 to 15, 15 to 18. So delta x is 3. I'm just going to make a note here. This is delta x. And then times, for the trapezoidal shortcut, if you will, we take the first y value plus 2 times the next 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 y value plus the last y value. If you would rather make individual trapezoids for all 6 of these, it's completely fine. Nothing wrong with that. This ends up being 32.7 meters. Of something I should have been doing for all of these, and I'm going to go back and fix this right now. I apologize. It says estimate, which is what we're doing. These really shouldn't be equal signs. These should be approximations. And also, technically, if you want to get crazy, this isn't the change in x, it's the change in t. These are t values, not x values. So, a double boo-boo. Yeah, like all of these should really be change in t, not change in x. They're t values. So, approximations. Sorry about this. Approximations. We got one more. All right. Find the average acceleration of the particle from t equals 3 to t equals 9. For what value of t is in the table is the average acceleration approximately equal to v prime of t? Explain your reasoning. All right. So average acceleration, as opposed to instantaneous acceleration. The average acceleration is going to come from taking the velocity at 3 minus the velocity at 9 over 3 minus 9. This is old school slope, algebra 1 slope. V of 3 is 2.7. It's right from the table. V of 9 is 1.3. 3 minus 9 is negative 6. It's going to give us 1.4 over negative 6. If you wanted to put that into a calculator, get a decimal, you could. Units, this is meters per second squared. Is the for what value of t in the table is this average acceleration approximately equal to v prime of t? Explain your reasoning. Well, this is alluding to the mean value theorem. The mean value theorem guarantees a value of c on the interval from 3 to 9 such that v prime of c equals the average rate of change And how do we know this is true? This is because 1, v of t is continuous. 2, v of t is differentiable. How do I know that? Because technically I don't know it. Now, v of t being continuous, I would imagine that all velocities would have to be continuous. Like, I think it would have to defy physics to not be the case. How do I know it's differentiable? I guess I don't know that for sure, but I'm assuming it is for some reason that either I have a good reason for and I don't remember, or I don't have a good reason. Let's just assume that it's differentiable. There really should be a good reason for us to know that it is or isn't, and we haven't been given a good reason for it is or it isn't. I'm just going to put assuming. And this right here is about negative 0.233. I'm looking. It says at what value is the average acceleration approximately equal? Well, this is negative. None of these velocities are negative. Oh, I'm sorry. That's because these aren't, we're not talking about velocity, we're talking about the acceleration. So if you look here, when is this about negative 0.233? From here to here is kind of close. That's dropping by 0.3. I mean, we're doing the best we can do here. We're supposed to approximate at t equals 6. The average acceleration is about the same as v prime of t, and that is a pretty rough estimate there. So just to be clear, like if these are the velocities, the difference between, actually that's not true either. I take that back because I'm just looking at the y values. I can look at the x values as well. So from here to here is 0.7 divided by 0.3. I want to be dividing the top number by the bottom. I guess I did say 6. Why did I say 6? This is 0.7 divided by 0.3. That's kind of close to that. So sorry, I got kind of fuzzy here at the end. It's late. I'm tired. I don't feel well. All excuses. So to reemphasize this, to take a horse that's dead and beat it until it's even more dead. The change in v here is negative 0.7. The change in t here is 3. 0.7 divided by 3. You know, we're in the neighborhood here. All right, that concludes that. There'll be, you know, this will work out better on the AP test than this problem did. All right, that concludes the notes for this section.